we go. So we're going to do converse and trigonometry. So some of y'all last class got to play with the little sticks and form triangles, and you were able to figure out how to determine if a triangle is going to be an acute triangle, an obtuse triangle, or a right triangle. Is everybody with me? So the way that we do it is through Pythagorean theorem. Okay? And you all, majority of y'all did this yesterday. So I'm just running through this quickly. All right. So if, I almost think of it as a war. Okay? If we're talking about a right triangle, we all know that sides A and B are your smaller sides, correct? And C, which is the hypotenuse, is always your bigger side. Is everybody with me? Did I lose anybody? When we're talking about the length of the sides? So, I think of it as a war. If the two smaller sides can be added together to be bigger, when I square them and add them together, to be bigger than the larger side, then the smaller sides, that means the smaller side's one, which is acute. Like an acute little angle. Tiny. Now, if the bigger, more stronger side is larger when you square it, that's when we say obtuse. It's going to be an obtuse triangle because the bigger, stronger side won. But if they set are equal to each other, that means that they are right for each other. Oh, they're right for each other. So, let's do an example. 3, 6, and 9. These are the lengths of my triangles. 3, 6, and 9. Just by looking at these lengths, which one is my hypotenuse? 9. Why, besides Richard, Aaron, Richard, is 9 the hypotenuse here? It's the largest. All right, so let's test it out. I'm going to do 3 square plus 6 square. And then I'm going to do 9 square. In your calculator, please put 3 square plus 6 square in your calculator. Come on. We don't have time to play. We have time to do this. 3 square plus 9 square. 3 square plus 6 square. 45. All right, and then what is 9 square? 81. So who won this war? The acute little triangles or the obtuse side? Oh, the obtuse side. So this would be an obtuse triangle. Is everybody with me? Now, what if I said 8, 9, and 10? 8, 9, and 10. Henry and Jordan at 8 o'clock. And Maria, Jaylene. You're not taking the test. You have guidance. All right, 8, 9, and 10. Go ahead and try it quickly. You should know which one is the... That's not you. That's me. This is not. 8, 9, and 10. You know which one is the bigger? So 8 square plus 9 square. And then you have a 10 square. So what's 8 square plus 9 square? 145. And then what is 10 square? So who won, the acute team or the obtuse team? Acute. So that means it's acute. Now, last one. So you get an example. 6, 8, 10. Do you see? Why is it acute? These are the smaller sides. That's the bigger side, correct? Do you agree with that, Jessica? Do you see the smaller sides one? They're bigger. So it's an acute. If the bigger side is bigger, it's obtuse. Go. All right. So I'm recording. You can watch it. 6 square plus 8 square. And then I have a 10 square. This becomes 100, 100. Therefore, they are equal, so they are right for each other. Okay? Geometry is just the study of right triangles. It is the relationship of right triangles. Okay? So, it is dealing with certain ratios. Is what you all are going to deal with in geometry. So, a ratio is the comparison of two quantities by division. So if I said there are 6 girls to every 12 boys in this class, that means that the ratio is 1 girl to every 2 guys. Okay? It is a ratio. It's 1 to 2. 1/2. Write this down. All right? Now, you all will have to memorize the ratios, or at least know how to get the ratios. The SOL gives them to you, but you need to know how to get the ratios from a right triangle. And I'm going to show you how. You have to pay attention and practice this. Okay? Are you ready? First of all, let's talk about ratios. Just draw this picture real quick. Draw this picture. Just draw that picture. Don't write the words. Draw the picture. 3, 12, and 13. 5, 12, and 13. Sorry. The rest of them are going to be a lot bigger than this. All right. So, we are going to do, and whatever I write now, you're going to write. What is the ratio of the length of the long leg to the length of the short leg? So we're doing long, whoops, don't write that. Long leg to short leg. What is the long leg on this triangle? Think about it. We're talking about the leg, not the hypotenuse. There's 2 legs and a hypotenuse. So 12 is the long leg. What would be the short leg? 5. Good. So that would be your ratio, 12 to 5. So our long leg is right here. Our short leg is right here, right? Yeah. What is 13 called in a right triangle? It starts with an H, the hypotenuse. And that's the only reason. It's not a leg, it's a hypotenuse, okay? Now, number 2 says, what's the ratio of the short leg to the hypotenuse? So what is the short leg here? 5. What is my hypotenuse here? 13. Pretty good? Those are the type of ratios you are going to do for trigonometry. Is everybody with me? All right. Does everybody have this before I move on? Opposite, adjacent, and the hypotenuse. The opposite side is the side across from the angle that I am talking about. The adjacent side, what does adjacent mean? Next to the side that I'm talking about. And the hypotenuse is always where? Across from what? The right angle. All right. So we are going to write the adjacent, the opposite, and the hypotenuse side in relationship to an angle. And they change according to what angle you're talking about. Okay? So, I want you to take your pencil, colored pencil. We're going to do the first one in relationship to A. If you have a highlighter, you may use your highlighter, or you may use your colored pencil. So, in relationship to A, let's see if I can do, nope, that don't work. In relationship to A, we are going to put our arc on A. So that is the angle I'm talking about. Angle A. Okay? Now, where is the hypotenuse? That is the easiest one to figure out. Where is your hypotenuse? AC. Good. So my hypotenuse is at AC. Good. Okay? Now, my adjacent side would always be the other side that creates the angle I'm talking about. Now, this is how I figure it out. I'm talking about angle A. Take your pencil or your highlighter, and let's highlight angle A. Do y'all see how I highlighted angle A? If you don't know how to highlight which angle A is, go to A and highlight the two lines that come from A. Those are the angle legs. Now, do you notice one of the sides I highlighted is the hypotenuse, right? The other side that I highlighted is the side next to the angle I'm talking about, which is your adjacent side. So the other side you highlight is always your adjacent side because it's next to the angle. And what I say is no gets an O. The side that was not highlighted is your opposite side. Boom. Because this side, BC, is opposite, if I draw a line from the angle, opposite of angle A. Is everybody with me? Now, I want you all to do it in reference to this angle. Let's go ahead and do it in reference to angle C. Highlight angle C and tell me what my O, opposite, my adjacent side would be. My hypotenuse is the one I can automatically do. Where is that? AC, good. And it's just because it's across from the right angle. Is everybody with me? Now, what would be my adjacent side? BC. If you need to, remember, I can highlight my angle that I'm talking about. The other side that is highlighted, you have to know your hypotenuse. The other side that's highlighted is your adjacent. And then your opposite side would be no gets an O. The opposite side is the one not highlighted. Is everybody with me? Now, we are going to take these and learn trigonometric ratios. Do you all notice, first of all, let's go back. Do y'all notice that these are different? Look at this. They're opposite because we're talking in relationship to a certain angle. We never highlight the right angle. Is everybody with me? Let's write that down. Never highlight the right angle. Never highlight the right angle. All right, so now we're going to talk about these trig ratios. Here they are. I'll give you 3 seconds to write this down. In trigonometry, there are 3 geometric ratios that you have to memorize. And it is, y'all probably seen these on your calculator. It is not sin. It is sine. These are just the abbreviations. Okay? So this is really spelled this way. Sine, cosine, and tangent. But on the calculator, they say sine, cos, and tan. Okay? Is everybody with me? Now, we always do these in reference to an angle. And because I don't know what angle, I don't have an angle here. In a generic term, I'm just going to use the Greek term theta. It looks like this. Oh, yes, please get that. This is number 4. Okay? So, there we are. Theta. Okay? Now, the sine ratio is the opposite side over the hypotenuse. Okay? Get your coloring. Now, the cosine ratio is the adjacent side over the hypotenuse. And the tangent is opposite over the adjacent side. Okay? Now, let's see what those letters would be if I put this in relationship. I'm going to say this is theta right there. That is the angle I'm talking about. So let's do the same thing we have been doing 2 seconds ago with putting the opposite, the adjacent, and the hypotenuse. Now, do I have to write the word opposite, the word adjacent, and the word hypotenuse? No. What we use is OH and A. So if I'm talking in relationship to this theta, I'm going to highlight this angle just like I did before. Is everybody with me? And I forgot to put my right angle in there. I'm highlighting that angle. We know what Z is. What does Z represent? The hypotenuse, right? So I'm going to put an H there. In reference to this theta, what does the X represent? Adjacent. Because it is the other side highlighted and next to the angle I'm talking about. And then what is this represented by? The opposite. So if I was to look at this, this would be Y over Z. Are you with me? This one would be X over Z. And the last one would be Y over X. Okay? Now, real quick, I'm going to give you one set to try on your own. I'm hitting the light. And then you all are we're going to see how you do. Are you ready? Here we go.